All right, so let's learn a new vocabulary word. We know what an atom is. An atom is a neutral element. So any element that is in its neutral state. Now, the new vocabulary word we're going to learn is called an ion. Ion means that it has unequal protons and electrons, so it has what we call an overall charge. There are two different types of ions. There's one called cation, and the other one is called anion. So, the key word is that they have the word ion in the name. So please don't call it cation and anion. You want to say cation and anion. So let's start with cations. Cations are usually metals that lose electrons to form positively charged ions called cations. So protons will stay the same, but because there are more protons than electrons, electrons are what we call lost. That means we lost some electrons. So in order to remember that cations are positive, think of the T as a plus sign. So that T becomes that plus sign. So if we wrote it out to the side again, instead of a T, you always can think cation. So cations are positive. Check out that word. All right, on the other side, you have an anion. Anions are usually when nonmetals gain electrons to form negatively charged particles called anions. So the protons are the same, but there are protons are less than the number of electrons. That means that we've gained electrons. That's how we become negative. Use the N in anions to remember that it means negative. Or you can think, hey, look at this A. That is a negative sign. So I know that anions are negative. Okay, so how can we apply this to our periodic table? How do we know why it's called a cation or an anion? So in order to do that, we are going to write some examples here. To get a full octet, remember, means 8. Basically, in order to look like a noble gas, because noble gas are the popular cool kids, everybody wants to be like a noble gas. That's their goal in life. Every element wants to be a noble gas. And so in order to look like a noble gas, every element wants 8 valence electrons. Remember, valence means outer electrons. Okay, so in order to properly draw the picture, I'm going to draw it on the next page, and then we're going to come back to this page and write up the quick summary. So, on this page right here, you have an example, lithium. It's in the first column, so that's an alkali metal. If you look up lithium on the periodic table, so really quick over here, you can see that lithium has 3 protons. So going back, a normal neutral lithium has 3 protons and 3 electrons. So if we draw 3 electrons, the first level will have 2 electrons, and then the second level is going to have that extra one, so a total of 3 electrons. Now, lithium wants to look like a noble gas, and in order for it to do that, it has a couple of options. It has that 1 valence electron sitting here right now. So the question is it easier to gain 7 more electrons to become a noble gas, or is it easier to lose 1 and look like the noble gas helium? Well, 1 versus 7, it's definitely easier to lose 1. So we're going to get rid of that electron, When we lose that electron, you got to remember that now our protons and electrons are uneven. So going back to this page, remember lithium has 3 protons normally. and then 3 electrons normally. If we lose one of the electrons, so I'm going to erase it here, then now we have an uneven amount. We have 3 protons and only 2 electrons. So 3 pluses and 2 minuses give us what kind of charge, right? And so here, losing 1 electron actually gives you a positive 1 charge because you have 1 more proton than you do electron. That plus means you have more pluses than minuses. Okay, so when you lose that electron, now lithium looks like this box right here, okay, and that looks like helium with 2 electrons. Now, when we went from here to here, the question is what happened to our size? So let's learn 2 more vocabulary words. Atomic radius is the size of a neutral atom. So a neutral element, what is its normal size? Okay, an ionic radius is the size of an ion after it has lost or gained electrons. So it's going to get smaller or larger depending on whether you gained or lost electrons. Over here with lithium, because we lost 1 electron, you can see that it lost an entire ring. So really quick right here, this ring is now gone. And because it's gone, we got smaller because we lost electrons. Well, specifically, we lost only 1 electron. Okay? And so if we go back to this page, we can sort of summarize it really quick. So here, we're going to lose 1 electron, okay? And because of that, there are more pluses than minuses, so we have a positive 1 charge. Because it is positive, remember the vocabulary word that we learned, that positive tells us that it's a cation. And when we lost that electron, our ionic radius became smaller because we lost electrons. And what we can see here is that this applies to every single element in the first group. All the elements in the first group is going to lose 1 electron, become a positive 1 charge, a cation, and the ionic radius is going to get smaller because it lost electrons. Okay, so let's apply this to group 2. Okay, an example that I used is beryllium. If you look on the periodic table over here, we see that beryllium has 4 protons and electrons in its neutral state. So I drew it for you over here, okay? Now, in order for beryllium to have 8 electrons, right, 8 valence electrons, that's its goal, it has 2 on the outer side. Question is it easier to gain 6 or lose 2? So 2 versus 6, it's easier to lose 2 electrons. Way easier to lose 2 than gain 6. Now, if we lose 2 electrons, let's think about what happens. So let's do a count here. Okay, you have 1, 2, 3, 4 protons normally. So 4 pluses. And normally 1, 2, 3, 4 minuses. Now, how many electrons are we going to lose in order for our beryllium to look like a noble gas? We said we're going to lose 2. So going back here, I'm going to erase this electron and this electron. And now I am with 2 electrons. So I have a plus 4, a minus 2. So what is my ionic charge? My ionic charge then becomes positive 2 because I have 2 more plus signs than negative signs. So if you look here, 2 more plus signs and negative signs. So this is positive 2. Okay? If it's positive, we call this a cation. Okay, so now let's draw it on our next page. Okay? If we're going to lose the outer 2, so we're going to lose this one and this one, then what does beryllium look like? So I'm going to draw Be. So it's going to have one ring with one electron here, one electron here. Because we lost 2, so I'm just down to 2. So look at the size difference. Did we get larger or did we get smaller? We definitely got smaller because we lost 2 electrons. Okay, and that's my little shorthand for electrons. Okay, so let's go back to the previous page and finish off this little summary here. We're going to get smaller because we are going to lose or we lost electrons. Okay. Let me put that number right there. All right, so now let's do one more example. Let's do our halogens. Our example here is fluorine. Now, if you look on the periodic table, fluorine is all the way over here. It has 9 protons and 9 electrons. If that's the case, right, it looks like this picture right here. So, the question is, in order for me to have 8 valence outer electrons, okay, the question is, what should I do? So right now I have 1, 2, 3, 4, 5, 6, 7 valence electrons. Is it easier to gain 1 or lose 7? Should I lose all 7 of these dots or just gain 1? The easy answer is we're just going to gain 1. Pretty simple enough. Now, going back, if we gain 1 electron, okay, so we're going to gain 1 electron. Let's do a count really quick. So we originally have 9, right, protons. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 plus signs. Now, I would have normally 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. Now, what did I say I was going to do? I said I was going to gain 1 more. So I have an extra negative symbol over here. Now I have 10 electrons. Now let's compare these numbers. 9 plus signs, 10 minus signs means my ionic charge is what? I have an extra negative. So my extra negative gives me a -1 charge. When it's negative, we call this an anion. Okay, -1 charge. So going back to the next screen, okay, we know that gaining 1 takes me to -1, and let's draw our picture here. So I have fluorine, and I normally have 1, 2 here. Then it goes 1, 2, 3, 4, 5, 6, 7, and I'm going to add my 8th dot. So now I look like a full noble gas. Now when you add an extra electron, we are going to get larger. Why? It's like adding another piece of accessory or piece of clothing because you gained electrons. Or here, you only gained a single electron. Okay, so this was our scratch work, so let's go back to our summary. Here, we're going to get larger because we gained electrons. Okay, perfect. Now, this 8th column is sort of moot because our 8th columns are noble gases. Noble gases are already happy because if everyone's goal is to be a noble gas, they're already there. So they lose or gain nothing. They have no charge. this doesn't apply, none of this applies because none of this applies, okay? They don't lose or gain anything because they're already a noble gas, okay? Now, this doesn't only happen with alkali, alkaline earth, and halogens. They can happen with other elements as well. And so this was our example here. Now, down here, you're going to try on your own to tell me how to fill out this chart. Okay, you're going to draw what it normally was here. Okay, is it lose or gain electrons, the ionic charge, ionic radius? So use this top part right here as a guide as to what the bottom part should look like down here. Once you feel like you have it, then you can check your answers. And I'm going to post it up right now, so I would pause before looking at all the answers.